and welcome to Polynomials 2.2, Graphing Polynomials in Factored Form. Okay, so 2.1 and 2.2 are pretty much exact opposite. Yeah, in 2.1, the lesson we just finished, you were given a graph and your job was to make the equation. In 2.2, you're given the equation and now your job is to make the graph. Okay, so we're going to go the complete opposite direction from what 2.1 did. Yeah. The good part is some of the things that you hopefully caught on to in 2.1 will carry over to 2.2. Not everything carries over nicely though. Yeah, there's going to be some parts of the graphing that are going to get real confusing, especially when it comes to the behavior part, the part where it's talking about passes through or hit and run or slows down. Okay, that's where usually the kids get stuck on every year. So you probably might want to rewind this video as many times as you need, yeah, or have to, so that you can get a lock-in on how the behavior is drawn, because that's what always gets the kids. They go, what? How did you get that? How did you do that? Right? And usually if it's a live lesson, you only can see it like once or twice or 3 times, depending on how many problems I do. So luckily this is taped, because if you miss the first couple of times, you can rewind it 10, 20, 30 more times if you need to. Okay, so let's start. And yeah, these things in this list right here are kind of like pointers or reminders as you do your graphs. And if you start making mistakes, then if you look at this list, you're like, oh man, I made this mistake, and the list warned me about it, but I didn't look at the list very good and I forgot about it, or I didn't realize it. Okay, so you might want to look at those lists also. Okay, so we have our equation, and it's not a very nice equation, negative 0.25. Well, I mean, there can be uglier than that, but yeah, normally we don't put decimals too much, I mean, until we get to this section. So negative 0.25 times the quantity x plus 4 times the quantity x plus 1 times the quantity x minus 3. Okay, so this is factored form of the equation. And that's a good thing, because if it's factored form of the equation, I can lock in on the x-intercepts super quickly. Yeah, we got negative 4 comma 0. Oops, let me get to pen mode. That would be nice. Negative 4 comma 0, and actually let's write it in blue. Negative 4, there we go, comma 0. And we have another one at negative 1 comma 0, and one more at 3 comma 0. And if you're thinking, why did you space out the coordinates like you did? And here's the reason. Because I'm going to take notice of the powers that are associated with each of these parentheses, and I'm going to write the behavior next to each of these coordinates. So I'm going to put PT, PT, and PT. So why did all 3 of these guys get PT? Well, because all 3 of these parentheses had power of 1. Okay, and here's what you got to do for me. When you write out this list of x-intercepts, yeah, you got to write the coordinates. That's a guarantee. That's a requirement. But another requirement is you got to write the behavior next to each of these coordinates. For me, for my kids. So if you're in another teacher's class and your teacher doesn't necessarily make you do that, then that's fine. But if you're in my class, it is a requirement to do both. You got to write the coordinates and you got to write the behavior. Okay? And if you don't write the PT or the SD or what was the last one? Hit and run, HR. If you don't write those acronyms, those letters next to each of these coordinates, then there's going to be a certain benchmark that pretty much talks about what is the behavior that you notice when you read the equation. It's going to kind of be something like that as far as what it means. It's not worded like that, but it kind of means that. Yeah, like when you look at the equation, what kind of behavior do you notice based on the numbers that you have in the equation? And the way to test to see that you can understand that, yeah, what numbers make certain behaviors come out, is for you to put these letters right next to the coordinates for me. Okay, so for my kids, yes, you have to do this. And if you don't, then when it comes time to evaluating that one certain benchmark that asks, do you understand what the numbers are doing to the behavior? I'm going to say, no, this kid doesn't understand because he's not writing these letters. Okay, so please make sure you write these letters next to the coordinates. All right, so next let's look at degree. And this is going to bring back a concept from a couple of lessons ago where you count x's. So let's count x's. So I got 1x, then I got another one, and I got one more. So I got 3 x's. So I'm going to put a 3 here. And 3 is an odd number. So that means it has opposite arrows. Okay? And you're going to ask me this question. do we have to write odd and opposite? And here's the response. Yes, you do. Because like I said, yeah, there's a benchmark that says when the student reads the equation, are they able to figure out what kind of behavior is going to be exhibited on the graph when they draw it? And it's not written in the exact same way that I just said it, but that's what's implied when you break down the benchmark as far as what it's saying. Yeah? And for you to prove that you understand what role the degree does, you got to write odd and opposite. Okay, and if you don't write that, then like I said, when it comes time to evaluate that one benchmark, I'm going to say, nope, this kid doesn't understand it because he didn't write the behavior. Okay, so make sure you do that. Okay, LC. LC is going to be when you grab all the numbers in front of the x's. So in this particular situation, it's going to be negative 0.25 because that's in the front of this x. Then you're going to have a 1 that's in front of this x, a 1 in front of that x, and a 1 in front of this x. So negative 0.25 times 1 times 1 times 1 is going to make negative 0.25. And from there, you're going to understand that this is a negative number. So your LC is negative, which means right side down. Okay, your LC is negative, so right side is down. Okay, to get the y-intercept, we kind of also did that on that, I think it was 5-3. I'm sorry, not 5-3. 1-3, polynomials 1-3. So y-intercept is going to be basically you plug in 0. And that's the most awesome number to ever plug in because it makes letters disappear, right? So you're going to plug in 0 and you're going to get this. Watch what happens. Negative 0.25. And then you're gonna plug a 0 in place of x, so you're gonna get 0 plus 4. Yeah, so it's gonna pretty much make the x useless because 0 plus 4 is just 4, right? Then you're gonna plug in a 0 for the next x, so 0 plus 1. And then you're gonna get 0 minus 3. So whenever you plug in 0, it makes the calculation so much easier. So negative 0.25 times 4 times 1 times negative 3. So you got a negative here, a negative there, so overall your answer guarantee is positive. You got 0.25 times 4, which is a 1. Then you got 1 times 1, which is 1. Then you got 1 times 3, which is 3. And if you're saying, wait, 1 times 3, doesn't that say negative 3? Yeah, I know it says negative 3, but I already know my answer is positive because this negative and this negative create a positive overall answer. Yeah, so that's why I tell you guys to do answers in pieces, right? Sign piece, number piece, and letters with powers piece. If you break it down one by one, then you don't care about negative 0.25. You don't care about negative 3. All you see is 0.25 times 4, which is 1. 1 times 1 is 1. 1 times 3 is 3. Okay, so you're going to put a 3 in this spot for the y-intercept, and you got your y-intercept coordinate. Okay, so the majority of the problem is done, and now all that's left is to graph this graph. So let's start putting our dots. So negative 4, 0, negative 1, 0, and 3, 0. And we have a y-intercept at 0, 3. Okay, we know our right side arrow faces down, so I'm going to put a little arrow facing down on the right. And because my right side arrow is down, what direction is my left side arrow going to be pointing in? Is my left side arrow going to be pointing down as well? Well, let's look. It says odd and opposite. So if my right side is going down, then my left side means it's going up. Okay? So now we have the basis for drawing my lines. And when you draw your lines, all you got to remember is you're going to connect all these 4 dots. And you got to remember, when you hit these x-intercept dots, you got to make sure you display the behavior that we have written next to each of these coordinates. So passes through, passes through, passes through. So let's do this. So my left side line is going to be going up on the left side. It's going to hit this dot. It's going to pass right through. Then at some point it's going to turn around. Does it matter where you turn around? No. Okay. In future math classes, yeah, they'll teach you how to figure out where it's going to turn around. But for now, we're not going to worry about that. So we're going to turn back around because we've got to hit this dot, right? Then we're going to come up. We're going to hit the y-intercept. Then eventually turn around again. And like I said, don't worry about where to turn around. just understand you gotta turn around because you gotta hit all these dots. Okay, and next to each of these x-intercept dots, I'm gonna put PT because that's the behavior I see next to each of these dots. PT, passes through behavior. Do you have to put the letters PT next to each of these dots? Yes, you do. Okay, and I'll explain why later on. Yeah, and it's gonna actually help you out when you actually put the kind of behavior that you just drew on the graph next to each of these dots. It's going to actually help you out a lot. Okay. All right, so don't mind me. There's going to be a couple of extra random noises happening now because my computer told me that my battery is dying, so I got to plug in. Okay, so sorry for the extra noise. All right, so this problem is done. Let's go to number 2. Okay, so let's look at our equation. 1/8 x plus 2 quantity squared times x minus 1 quantity cubed. Okay, so let's get my x-intercepts. So I got -2, 0, which has a power of 2, so that's going to imply hit and run behavior. Then I got another x-intercept at 2, 0, which has a power of 3, so that's slow down behavior. Okay, so next one, LC. So let's see, what are all my numbers in front of the x's? So I got 1/8, I got a 1, I'm going to write the 1 twice because it's squared. Then I got a 1 over here, I'm going to write that one 3 times because it's cubed. So 1/8 times 1 times 1 times 1 times 1 times 1, which is just going to be positive 1/8. And because I have a positive LC, that means my right side is up. Okay? And my degree, I'm going to count x's. So 1, 2. Well, why did I hit this x twice? 1, 2. Well, because the power is 2. Okay, so 1, 2, 3, 4, 5. So why did I hit this x 3 times? Well, because his power is 3. So 2 x's here, 3 x's there. That makes a degree of 5. And 5 is an odd number, which is going to imply opposite arrow behavior. Okay, so y-intercept, we're going to plug in a 0, right? So I can actually just write 0, comma already because I know guarantee it's going to be a 0 in the x spot. So 1/8. And then we're going to have 0 plus 2. And I'm going to write that twice because it's squared. Then 0 minus 2. I'm going to write that 3 times because, oops. Okay, might help if I write the 0 first because it's cubed. Okay, so I got 1/8 times 2 times 2 times -2 times -2 times -2. So overall my answer guarantee is negative because 3 negatives make a negative answer. I got 2 times 2 times 2 times 2 times 2. That makes 32 on the top of the fraction, 8 on the bottom, and that simplifies to -4. So I put a -4 here. Okay, so let's plot everything out. I got -2, 0, which is going to be, I'll put the behavior later on. Then I got 2, 0. Then I got 0, -4. And I got right side arrow is up. And my opposite behavior, so if my right side is up, that means my left side is going down. Okay, and then I got to do hit and run behavior on this first dot. And slows down behavior on the second dot. Okay, so let's do this. So my left side arrow is on the bottom. Okay, so I'm gonna go up, right? So notice how my left side arrow is pointing down, right? So I go up, I'm gonna approach this dot, I'm gonna hit it, and this is where kids make a mistake. When they turn around, when they make the mistake, they turn around after they hit the dot. Okay, when you do hit and run, you're turning around as soon as you hit the dot. Yeah, so actually, let me draw a little bit better. Because, yeah, so as soon as I hit the dot, I turn around. Okay, then I'm gonna hit the y-intercept next. Then I'm gonna turn around because I gotta make sure I hit the next dot. So I turn around at any height you want. Then I'm going to slow it down so I flatten out. So you see what I did? I went flat as soon as I hit the dot, right? So I went up, I went up, I went up, and then I leveled out. I went flat when I hit the dot. So notice how when I make contact with the dot, I'm leveling out. I'm flat pretty much. And then I go back in the upward direction because the right side has to point up. Okay, so this behavior right here, the slowdown behavior, is where kids always have trouble. They cannot draw it nicely for some reason. Yeah, I mean, yeah, it's hard to draw, right? So you kind of almost have to over-exaggerate it. Yeah, and because sometimes kids don't draw it really nicely, when they draw it, sometimes they make it look like pass-through behavior. And when I look at the graph, I'm like, whoa, what did this kid draw? I know they're supposed to draw slowdown behavior, but it looks like pass-through behavior to me. And that's why I make you guys label the dots. Because if you draw it ugly, and in my brain I'm like, oh, okay, this could be pass-through, or it could be slows down behavior. Which one is it? Yeah, I won't know. So my natural instinct is going to be, well, if I don't know, then I'm just going to mark it wrong. Yeah. So the way I got around that is, you can draw it nice, you can draw it ugly, but as long as you have the label that this is supposed to be slowdown behavior at this dot, then I'll trust what you label it. Yeah, because not everybody can draw nicely. Yeah, look at me, my graph was ugly. Look at how shaky my line is, right? So there's no way I'm a good graph artist at all. Yeah, but that's why you see me over exaggerate the behavior you see here, so that when I slow down, yeah, I really went flat when I hit that dot. Yeah, some people might not make it that flat at that dot. You might make it a little bit shorter. So sometimes it's hard to see what kind of behavior it is, and that's why, like I said, I make you guys label the dots with the behavior that is supposed to be displayed. Okay? All right, so you can rewind this particular problem as many times as you need. Let's look at number 3. Okay, so we got our equation. Okay, I'm going to go in reverse order. So I'm going to do the one on the far right first. So 3, 0. And that one is going to be hit and run behavior because it's power of 2. Then I got negative 2, 0. And that's power of 1, so that's pass through PT. And then this next one, x to the third. Yeah, so whenever you just see a little letter like x to the third or x squared, x to the first, whatever x, if you just see x by itself all the way in the front, all by itself without no pluses or minuses, you know that the coordinate that made him is 0, 0. Okay, so just keep that in mind. And ooh, I didn't leave enough space to write slow down, so I'll just write it like that, SD, like that. Okay, so just keep in mind, yeah, when it's a regular plain old x, just all by itself, just like that, it's 0, 0. Okay. All right, so let's do degree. Let's count my x's. So 1, 2, 3, 4, 5, 6. So degree is 6. And you know what happens every time my kids do this? They count the wrong amount. Yeah, they forget about the powers. They just literally see 3 x's, so they go, oh yeah, my degree is 3. Yeah, so be careful, please. So degree is 6. That is an even number. So that's going to imply same. Arrows in the same direction. Okay. So LC is going to be all my numbers in front of the x, so 0.1 times 1 times 1. Oops, why did I write 1? Oh yeah, times 1. Okay, so this first one is for this guy. These other 2 ones are for the other guy with the power of 2. Okay, and I don't have to write 0.1 3 times because this 3 does not affect 0.1. This 3 only affects x. So please do not write 0.1 3 times. Yeah, you got 0.1 one time and then 3 x's. So please make sure you don't make that mistake and write 0.1 3 times. Okay, because kids always do that also. So your LC is going to be positive 0.1, and this is a positive LC, so that means my right side is going in the upward direction. Okay, so let's find my y-intercept. I know guarantee the x value is 0, so let's plug in 0. So 0.1 times 0 times 0 times 0, because it's x to the third, times 0 plus 2 times 0 minus 3, 2 times. Okay, but I already know how this is going to all play out, because once I see multiplied by 0, yeah, once you see multiplied by 0, your whole answer is going to be 0. Okay, it doesn't matter that you have 0 plus 2 and 0 minus 3 and 0 minus 3. It doesn't matter about all that. Once you see that you're multiplying by 0, yeah, then your overall answer is only just going to be 0. Yeah, so your y-intercept is at 0, 0 also. So let's plot out my dots. So I got a x-intercept at 0, 0. I got another one at negative 2, 0. I got one at 3, 0. And, oh, my y-intercept is at the exact same spot that my x-intercept is at. Okay, my right side arrow is facing up. I got same behavior, so my left side arrow is also facing up. Okay, and this first dot's going to be, I almost made a mistake. This first dot is passes through. Okay, the second dot is slow down. And this third dot is hit and run. Okay, so this is going to be a little bit tricky to draw. Okay, so you got to be real careful. Yeah, so your left side arrow is on the top. So you're going to hit this dot, you're going to pass through, you're going to turn around, you're going to level off and get flat when you hit that dot, then go up, right? So you're going to remember, what slows down behavior, this is going up, it's flattening out, then it keeps on going up again. Okay? Then you eventually have to turn back around because you got to hit this dot, so turn around, and when you hit this dot, you're going to do hit and run. And you're going to go back in that upward direction. Okay? And a very common mistake that kids always do is they hit the x-axis at spots they're not supposed to. Yeah, because connecting these dots can get confusing. And when kids make mistakes, they hit the x-axis too many times. That's why we draw the dots, because the dots tell you where you're allowed to hit the x-axis. So kids that don't draw the dots, they hit the x-axis all over the place. Yeah, they hit them in spots they're not supposed to. I'm like, why do you hit the x-axis at that spot? You don't have an x-intercept coordinate at that spot, do you? And go, oh yeah, that's right. I don't. Yeah, why did I hit the x-axis at that spot? Yeah, and it's just because you're trying to make all these things, these behaviors happen, that you forget that you're not allowed to hit the x-axis, yeah, at other spots other than these dots. So it gets confusing. All right, so the hardest part of today's lesson is probably going to be connecting the dots and drawing the behavior. So it'll take time to get used to, but you'll get used to it. Yeah, you just got to practice. That's like anything else. Math is like a repetition kind of a subject, where if you don't practice enough times, you're not going to get the skills necessary to master it. Okay, so good luck with this lesson, and I will see you in class. Bye-bye.